Hi girls, this is Ms. Blaufuss. This is in between 2.7 and 2.8, and it's a supplementary lesson. It's called piecewise functions. So in this lesson, we're going to focus on domain and range and graphing. These are linear functions, but we're going to split them up into these two new types of functions. We have piecewise functions and then a subcategory of that, which is step functions. So a couple key terms: piecewise function. A piecewise function has at least two equations, and each equation applies to a different part of the function's domain. And the second term we have is called a step function. A step function is a piecewise function, but with a step function, the graph looks like a set of stairs. The domain is continuous, and so the definition of step function is that there is a constant value over each part of the function's domain. And we'll do a few step functions in this lesson, so you can kind of see what they look like. So those are our key terms. So the first thing we're going to do is focus on evaluating functions. So in a piecewise function, we have two sets of a domain. We have the set where x is less than -1, and we have the set if x is greater than 1. In the first one, anytime we have a value less than or equal to 1, we're going to use this first equation, where g of x equals 2x minus 1. That's if x is less than or equal to 1. So for this one, -1 is less than or equal to 1, so we're going to use 2x minus 1. For the second one, g of 1, that's when x is less than or equal to 1. It's equal to 1, so we're going to use 2x minus 1. And for the third one, g of 5, 5 is greater than 1, so we're going to use the second one. So we're going to use, for g of 5, 3x plus 1. Okay, so now let's evaluate these functions. The first one, g of -1. The function g when x is -1 equals 2 times x, which is -1, minus 1. So g of -1 equals -2 minus 1, which is -3. The second one, g of 1, equals 2 times x, which is 1, minus 1. So g of 1 equals 2 minus 1, which is 1. And then the last one, since 5 is greater than 1, we're going to use g of 5, but we're going to say equals 3 times 5, 3x plus 1. And again, that's this function here, we're using this because our x is greater than 1. So g of 5 equals 15 plus 1, which is 16. So with piecewise functions, you have your domain is split up into pieces, and you have to use the equation that satisfies that section of the domain. So now try this next one on your own. Please pause the video while you work and unpause for the solution. Okay, here's the solution for this piecewise function evaluating f of -3, f of -1, and f of 5. When x is -3, -3 is less than -1, so we use x minus 4, and we substitute in -3 for x, and we get f of -3 equals -7. For the second one, f of -1, since -1 is greater than or equal to -1, it's equal to, we have to use the second function, 2x plus 1, and we substitute -1 in for x, and we get f of -1 equals -1. And for the third function, where x is 5, we're evaluating the function when x is 5. 5 is greater than or equal to -1, so we use 2x plus 1 and substitute in 5 for 2, and we get f of 5 equals 11. Now the second part of piecewise functions is graphing the function, and this is where you'll see that the graphs look a little bit different than normal functions that we've been graphing so far. So we have our piecewise function, the function f of x equals something when the -3 halves x minus 1 if the domain, if x is less than -2. F of x equals x plus 1 if the domain is between -2 and 1. And f of x equals 3 if x equals 1. Oh, actually, on your note sheet, I need you to change that. It says x equals, but it should say if x is greater than 1. We already included 1 up here. 1 is already included. So your note sheet should say f of x equals 3 if x is greater than 1. Okay, so we're going to graph this. The first thing we're going to do is look at our first set of domain. So everything when x is less than -2. Now, strictly less than, this means does not include -2. So if you think of your number line, if you're graphing something on a number line, and you wanted to say something but not including -2, you use a circle. Same thing with piecewise functions. We're going to use a circle for strictly less than or strictly greater than. And then if you were to include -2, you would use a dot. So we're going to stick with that method when we're graphing piecewise functions. Okay, so the first part we want to do is look at the graph for everything to the left of -2. So we're going to substitute in -2 in our first equation. -3 halves times -2 minus 1. And this is what our graph is going to look like for everything left of -2. So we get 3 minus 1. Okay, so when our x is -2, our y is +2. So that's where our domain ends with this function, but it does not include that point. Okay, and from there we can graph the line to the left of -2. We want to do to the left of -2 because we want it to be true for everything where x is less than -2. So I'm just gonna use the slope, -3 halves. So that's my rise, 3 over -2. And it's gonna go on forever that way. I'm going to use a solid line because it does include all of those points, just not -2, 2. So here's my graph for the first part of that domain. When x is less than -2, that's what my graph looks like. But now I need to figure out the second part of my domain, x plus 1. And that's true anywhere between -2, including -2, and less than or equal to 1. So I'm going to take both of those values, and I'm going to solve my f of x when x is -2. So f of -2 equals -1, and I'm going to plot that point. So when x is -2, my y is -1, and that includes this point because it's less than or equal to x, or x is greater than or equal to -2. And then I'm going to do the same thing, but I'm going to solve for the maximum of this domain, where x is 1. So f of 1 equals x, which is 1 plus 1, which equals 2. So when my x is 1, my y is 2. Function of x is 2. And then I'm going to graph that. Now notice I don't have arrows on this line because it does not continue. It only is for that domain when x is between -2 and +1. Then I'm going to do the same thing for x is greater than 1. So again, I want to start with my minimum domain. So, oops. So I'm going to start with my f of 1. And when my x is 1, my y is 3. It tells us right here. There's no function, it just says y equals 3. And that does not include 1. So 1, 3, I'm going to use a circle because it does not include that. And then anything greater than that, y is still going to be 3, and that's going to continue. Okay, I want you to try to graph this second one on your own. So please solve for each part of the domain. Start with the minimum, and then end if it has a maximum, and graph each of those separately. Use a circle if it does not include the point, and use a dot if it does. So please pause the video while you work, and you can unpause for the solution. Okay, so here's the solution for this problem that you just worked on. And so you want to start with x at -1. That's our first domain here. You want to use -1, and then you can use the second value if you'd like, or you can use the slope, but graph that f of x equals x for anything less than -1. So f of -1, if you plug that in, you got -1. And you're going to graph this with a circle because it does not include -1. Then for the second one, x plus 1, if x is greater than -1 and less than 2, less than or equal to 2, that does include those points. So on the graph, you can see that when x is -1, y is 0, and that includes that point. This part of the graph includes that point. And when x is 2, y is 3. And again, that is included in that graph. And then lastly, f of 2 equals -1. Does not include 2, but your y is always going to be -1. So it does not include 2, so we used a circle here. But go going forward, anything greater than 2, y is going to be 1. So you have one more piecewise function. We'll just do this one together. So please follow along on your note sheet. For anything, any value of x that's greater than 3, so this one, pay attention to how the signs are facing, because this one we have x is greater than 3 first, and then x is less than or equal to 3 second. So we have to pay attention to the signs. So anything greater than 3, we'll do that first. And we're going to start with 3. We get 2 times 3 minus 3, which is 6 minus 3, which is 3. So let's first graph this point, and we're going to use a circle because it's strictly x is greater than. So our first point is 3, 3, and we're going to use a circle for that. And then that rule applies anytime x is larger than 3. So it applies when x is 4 or 5 or anything to the right of 3. So we can use the slope to continue this graph. Our slope is 2. So we go up 2 over 1. That's another point. And we're going to draw this line. And it's going to continue always as x is larger than 3. For the second one, it's when x is less than or equal to 3. So we're still going to do the same thing. We're going to use 3 as our value because that's our maximum. And here we're saying it's greater than or equal to. I want my green. Greater than or equal to 3. So when we graph this, we're going to use a dot. So at the 3, but this time we're using negative x plus 2. So negative 3 plus 2, which equals negative 1. So we're going to graph that. 3, negative 1. So we're going to start with 3. When we substituted 3 to our equation, negative x plus 2, we get negative 1. And that includes that point. So we have to use the dot. And then from there, again, you can use another point that's less than 3, or you can use the slope. If we chose another point that's less than 3, let's say 0, for example, when our x is 0, our y is 2. So we can graph that point. X is 0, y is 2. And then since it's linear, we can connect these points. You could have also chose to use the slope. So in this case, our slope is negative 1. So we'll go up 1 unit and to the left 1 unit. So this is always going to be true when x is less than or equal to 3. But the equation negative x plus 2 equals our function, or our y. Okay, this next function is a little bit different, but we can start the same way. But if you notice here, it's just a value. So y equals negative 1, or y equals 1, or y equals 3. Those are all going to be horizontal lines. So it's a little bit different than the piecewise functions that we just graphed in the previous couple examples, but we can use the same process. So for the first one, f of x, we're going to start with negative 3. And we're going to go to 1. So f of negative 3 equals negative 1. And f of 1 equals negative 1. So let's graph those 2 points. Negative 3 is included. 1 is not included. Or negative 1 is not included. So our first point, negative 3, negative 1. Use a dot for this because this is included in the graph. And then oops, that should say f of -1 equals -1. F of -1, so when x is -1, y is -1. That is strictly when x is less than -1, so it is not included. So here's our first part of our function. The second part is f of x equals 1. So we're going to start with -1 because that's our minimum here. So f of -1 equals 1, and then our maximum for this piece is 1. F of 1 equals 1. So let's graph those 2 points. -1 is included in the graph. 1, positive 1 is not included. So -1, 1, this is included in our graph. Positive 1, 1 is not included. So here's our second piece. And the third part, f of x equals 3 when x is greater than or equal to 1 and less than 3. So f of 1 equals 3. F of 3 equals 3. And again, f of 1, x as 1 is included in this graph. So 1, 3, we're going to use a dot for that. It's included. But 3, 3 is not included because it's strictly when x is less than 3. And at this point here, right there, x is not less than 3, but when x is 2.999999, that point is included. Okay, so if you look at this graph, it looks a little bit different than our previous graphs. This is called a step function. So if you remember from the beginning, step function is a piecewise function where it looks like a set of stairs. So it's continuous. There's a constant value over each part of the function's domain. So there's always a value here. So this is included, although this is not. -1 is included here, but not here, and so on. So our function's domain goes from -3 to 3, and each of those values are included in our graph. So this last one, please try on your own. This is another step function, piecewise function. So try this on your own and pause the video while you work and unpause for the solution. So this next one is a piecewise function, which is a step function. So it's still a piecewise function, but it has a special name. So the first part of our step is anything between 0 and 1, y equals 1. Anything between 1 and 2, y equals 2. And anything between 2 and 3, y equals 3. So again, use the circles to indicate that that point is not included in the graph, and use the dots to indicate the point is included in the graph. So please jot down any notes you have. I know this video is a little bit longer, but jot down any notes that you have, and please bring those to comms, and we will discuss. Thank you.